Hello, this is Pre-Algebra Lesson 3-9. We have started working on square roots, and this is going to be building on that a little bit. So let's do a quick review. We learned that if we want to find the square root of a number, we need to find what number multiplies by itself to get that number. So the square root of 16, for the square root of 16, we're going to say what times itself equals 16. We are doing the reverse of squaring a number, so we're working backwards. Well, 4 times 4 equals 16, so the square root of 16 is 4. Now let's think about what I mean by working backwards. If we wanted to know what 4 squared was, we would say 4 times 4 equals 16. But when we want to find the square root of a number, that's where we're doing the backwards work. We're saying what times itself equals that. So 4 times itself equals 16. Therefore, the square root of 16 is 4. The square root of 25 would be 5. The square root of 9 would be 3. All right, so we've got that. Now let's build on that just a little bit. There are a lot of numbers that don't have a perfect square root. We call numbers that do have a perfect square root a perfect square. All of those numbers that I just wrote on the board for you, 16, 25, 9, those are all perfect squares. It means that a whole number times itself equals the number that we were trying to find the square root of. 100 is another perfect square. 121 is a perfect square, 144, 36, 49, 64. Those are all things that are the answers to problems like 7 times 7, 8 times 8, 11 times 11, 12 times 12, etc. So remember, a perfect square is a number that has a whole number that can be multiplied by itself, like 4 times 4, 4 times itself, and 4 is a whole number. 4 times 4 equals 16, so 16 is the perfect square because a whole number times itself equals 16. But today we're going to be looking at numbers that are not perfect squares, like the number 30. If we wanted to find the square root of 30, there is no whole number that multiplies by itself to get 30. So we have to do some trial and error. We easily will have many math problems that ask us to find the square root of numbers that are not perfect squares. So on a calculator, that's a pretty easy thing to do, and we'll look at that today. But at times we need to be able to reason our way through that process. So let's think about it. What numbers would the square root of 30 be in between? Well, I'm going to start thinking. Things that the answer would be close to 30. 5 times 5 is 25, but that's too small. 6 times 6 is 36, but that's too big. But what that helps me find is what two whole numbers, I'm going to turn that just a little bit, what two whole numbers our square root of 30 is going to be in between. It's going to be in between 5 and 6. Let's look at another one. Let's think about the square root of 10. Well, there's no whole number that multiplies by itself to get 10, so 10 is not a perfect square. So let's think about things that would be close to that. I know that 3 times 3 is 9. That's probably going to be my closest. And then I know that 4 times 4 is 16. That's a long ways away from 10, but we know that the square root of 10 has to fall in between those two numbers. If this one is 3 times 3 is 9, so this one, the square root of 9 would be 3. And let me get my pen working when I hold it correctly. And we know that 4 times 4 is 16, so the square root of 16 is 4. So we know that the square root of 10 is in between those two whole numbers. So you'll have homework questions like that. That's a pretty easy process. So let's move on to the next thing. And your book encourages you to do this part with trial and error as well. And I am actually going to let you use a calculator on this. It's the same exact process, just with a lot more detail. So let's look at example 2 on page 150. Again, this is lesson 3-9. Example 2 is a word problem, and I'll read it to you. It says you want to install a square skylight that has an area of 300 square inches. So I'm going to write that down, 300. Calculate the length of each side and then the length of the amount of trim that you will need to go around the skylight to the nearest tenth of an inch. So this is going to be a multi-step problem. The first thing we want to do is find out what one side of this square skylight is. Now remember, when we're dealing with a square, all of our sides are the same. So whatever one side is, the other side is going to be the exact same. So I've put an S for each of the sides. In this case, side squared is going to be the area. And so we square that to find the side. Could we work backwards if we knew the area? Could we say the square root of the area and find one of the sides? Yes, it's just simply a square root problem. So we're going to find the square root of 300, which is what they told us the area is. We've got to find the square root of 300 to the nearest tenth to find out what one side is. Now, we could use our trial and error approach. I could say, okay, let's see, 10 times 10 is 100. No, that's way too small. 20 times 20 is 400. That's too big. I could try 15 times 15. I could try 19 times 19. And I could keep narrowing, trying to find as close as possible what two whole numbers that square root is going to be. And I'll tell you that it would fall between 17 and 18. And then I could start doing that same multiplication with decimals, like 17.2, 17.3, 17.4, getting as close to 300 as possible. So for example, I would say 17.2 times 17.2, or 17.3 times 17.3, or 17.4 times 17.4. And at some point, I would get as close to that 300 as I could. But I am going to bless you by letting you use a calculator on this. So it's a good time to start practicing square roots on a calculator. When we do that, all that you're going to do, depending on how your calculator works, is you're going to enter your number and you're going to enter your square root sign. In some calculators, you will do the square root sign first, especially if you have a graphing calculator. And on some calculators, you'll enter your number first and then do the square root sign. So, and let me tell you, if you have a graphing calculator, your square root is usually going to be above one of the buttons, so you'll have to press Shift and then the button that the square root sign is above. So you would press Shift, square root, and then your 300, and then enter, and it would give you a whole number and then a decimal and then the decimal numbers that follow. If you're using a different kind of calculator, you will simply enter your 300 and then you'll press your square root button, and a lot of calculators actually have a square root button without having to press a shift or anything. So you would say 300 square root button equals, and that would give you the square root. So that's pretty easy, and what we would find is that we could use 17.3 as our side length after doing that math on the calculator. They asked us to round to the nearest tenth, so you would simply need to use your rounding techniques and get that. So now we have one side of this square, but remember that what the problem also asks is for us to find the perimeter. Be careful not to stop before your answer is complete. We were not simply finding a side of the square, we were finding the perimeter. If all of these sides are S, or all of them are equal, we're simply going to say 17.3 plus 17.3 plus 17.3 plus 17.3. Or we have a much easier way to do that. We can say 17.3 squared. All right, because side times side equals area, or length times width equals area. Okay, so we, I think, have our final answer on that problem. We do. It was the finding the side and finding the perimeter. All right. The next thing is example 3, and it is using a calculator to estimate the value of a square root, which is what I taught you in example 2, but it's a good explanation of that, so, or at least an example of that, so you can use that if needed. And I think that that's all that we have for that lesson. Let me see what the time is like, and then we may do a couple of examples. Oh yeah, we're good. Okay, so if I wanted you to find what two whole numbers the square root of 55 was in between, we would start One thing that comes to mind for me that's close to this is 49, which is a perfect square. The square root of 49 is 7. So that's pretty close to 55, that 49 is. Let's think of another perfect square that's close to this. 64 is, square root of 64 is a perfect square because 8 times 8 is 64. So I know that the square root of 55 is going to be in between the whole numbers 7 and 8. Let's do one more. This one is actually going to be dealing with integers, not just whole numbers. Because this time, this negative tells us that we're going to be dealing with a negative answer. So first we'll look at finding the square root of 90, or as what two whole numbers it's in between. But then, because those are going to be negatives, they're going to be integers, because integers are positive and negative whole numbers. So let's see. 8 times 8 would be 64. That's not even close. 9 times 9 would be 81. That's probably about as close as we're going to get on the lower end. So that's our first number. And then the next number that I can think of that would be close is 10 times 10. 10 times 10 is 100, and that's a little too big. But of course, there's no whole number in between 9 and 10. So our square root for 90 is between 9 and 10. But this, again, is the negative square root of 90. So it's actually going to be between negative 9 and negative 10. All right, I think that's all we need to do on that lesson. I'm going to end this video, and I will start a video for lesson 3-10.